All right, so here's another question for mastering. And this is related to how the structure of the acid relates to the strength of the acid. And so this first one, we are given a series of compounds and we want to rank them as far as what is the strongest acid to what is the weakest acid. So you'll want to look at there's a little tutorial at the top of the problem, but the section in my acid-base notes in the 4th edition, that's chapter 16. If you're in a 5th edition or beyond, it's probably chapter 17. But in my notes on that, I have a section at the end. I think it might be the very last thing that we talk about there. But what we're looking at is we're actually looking at the actual bonding and periodic trends and polarization. And so here, when we're talking about most of these binary acids, what we're looking at is when you're looking at the hydrogen bond to whatever it is, the weaker this bond is, so a weaker bond means stronger acid. So it's kind of opposite of what you would think, okay? So weaker bond means stronger acid. Remember, strong acids are ones that lose this hydrogen easily. So generally, as we go down the group, you have larger atoms, and so you have lower electronegativity as you go down, and then you get increasing electronegativity this way. So here we go. Let's look at this. So we know our strongest acids are going to be these because they're on our list of strong acids. So which one is stronger, Br or Cl? If you look, I don't have my periodic table on me, but bromine is below chlorine. So bromine would be a stronger acid than HCl. Which you know that. You can go, well, these are definitely stronger than water. Now we need to look at water versus this lithium hydride. So they're going to go over here somewhere. Well, what do you notice about lithium hydride? Lithium has a charge of +1, which means the hydrogen is -1. Is this thing going to put off any positive hydrogen ions? No. So this is like not hardly even an acid. I mean, if it's going to put on hydrogen ions, they're going to be negative. That's not good. So that's going to go here. And so water is going to be somewhere in the middle. So when you're looking at these binary acids, the further down you go, the stronger the acid down the halide group, which is why fluorine, which is up here in the top corner, is the most electronegative, and so it really likes to hold on to that hydrogen. So if you have a stronger bond, like HF, then you have a weaker acid. Flipping on to the other one, here we're given some Ka values, and we're given various sulfur acid combinations. Now, when it says Ka very large, basically means there's not a Ka value. That means it's a strong acid. You should be able to look on this list of these and identify which one is a strong acid. I'm going to let you do that. Hopefully you have figured out which one that is. Look carefully at the two of them that look similar, and you'll probably figure it out. Now, the next thing we need to know, notice this is 5 orders of magnitude weaker than this one. And here we're also dealing with oxyacids versus binary acids. So 2 elements versus acids that have oxygen in them. So oxyacids are mostly going to be pretty strong. So that pretty much just answers the question. But let's go ahead and look at this. And I don't go over it in the notes as much, but you can also look at oxidation number of the central atom. So we're not drawing Lewis structures. We're not talking about formal charge. But let's look at this H2SO3. Make sure you can see that. Yes. So, and this is good practice for when we get into electrochemistry and you got to assign oxidation numbers again. So in a neutral compound, they all have to add up to 0. These are all nonmetals, so we start with the table, which I would give you the table. It says hydrogen's +1, and then we would get to oxygen, which is -2. So we know that 2 times +1 for the hydrogens, plus this is an S for sulfur, plus 3 times -2 is going to equal 0. So that gives me what? 2 minus 6 plus S, this is S, not a 5, equals 0. So S is 4, +4. So let's look at that. This is just another strategy you can use. Let's look at, so the higher this number is, so the higher it is, the stronger the acid. So let's look at H2SO4. You can also look at a Lewis structure and determine it that way, but y'all generally don't like that. So this is +1, this is -2. So we have 2 plus sulfur minus 8 is going to equal 0. So here you find sulfur is +6. So that would say this is the stronger acid. Using the same strategy for the hydrogen sulfide gas, or dihydrogen sulfide, hydrosulfuric acid, all those are acceptable. All right, so on the table, this is +1, and there's 2 of them, so this has to be -2. So here you're dealing with, we want larger oxidation numbers. So if we do that, this would be the weakest, this would be in the middle, and this would be the strongest. So there's several strategies you can use, or you can just guess, but the explanation is always better.